Okay, sorry. Good morning, good afternoon, good evening. Welcome back to another coding not so everyday until I get a job. This is day 140 and wow, holy, okay. By day 150, I might need to post it on LinkedIn because, I really need to get a dev job. But in the meantime, in the 10 days, let's maximize our knowledge of DSA. So JavaScript DSA. Save. Let's go here, and then we can just shut this off. Turn this off. Pop-up chat. Test. Okay, cool. Okay, so we are on this 17th video. I think it's gonna explain the answer.
Let's begin by defining the function signature.
I'll open the previous folder. Wait, have we done the binary search or no? We haven't done the binary search. Why is it skipped? Okay.
In the previous video, we had a look at the linear.
We only did linear search, by the way, so it's not this one.
We had a look at the linear search algorithm, which has a linear time complexity. In this video, let's take a look at the binary search algorithm. Here is the problem statement. Given a sorted array of n elements and a target element t, find the index of t in the array.
Okay, I don't really know how to do it.
-1 if the element is not found.
In binary.
A very important point to make note of here is that binary search only works on a sorted array. If you do not have a sorted array, you can choose to use linear search or sort the array first and then apply binary search.
How do you apply binary search?
Had a look at in the previous video hold good for binary search as well, so let's reuse them.
Okay, so it's already
have a sorted array with 5 numbers, -5, 2, 4, 6, and 10, with target element is equal to 10. Our solution should return 4 since 10 is at index 4.
Does JavaScript have like a sort function? I think they do have a sort function, no?
Should return 3, and with the same array but t is equal to 20, the solution should return -1 as 20 is not present in the array. If you have understood the problem statement, please pause the video and try to solve the problem.
Okay, I don't know how to do the binary search one, so I'm not entirely sure. So I think I'm gonna see, because I'm not entirely sure what does binary search mean.
All right, let's now solve the problem together.
Sorry, but it is what it is, I guess.
The code, let's understand how we should go about this in pseudocode. I have the sorted array on the right and the target element in green. We need to find out the index of number 6 in the array. Here is the pseudocode for binary search. If the array is empty, return -1 as the element cannot be found.
If array.length,
find the middle element in the array.
Okay, yeah, I remember, yeah.
Middle element, return the middle element index. If target is less than the middle element, binary search left half of the array. If target is greater than middle element, binary search right half of the array. Let's understand how this.
Oh, it's no. Oh, okay, yeah, I remember. It's the one that keeps splitting it, right?
Step 1, since the array is not empty, we find the middle element in the array. That is 4. Now 6 is not equal to 4. We then check if target is lesser than the middle element.
Okay, yeah, okay, yeah.
Is not less than 4.
So we go to the right.
4. If target is greater than the middle element, we know that the target element has to lie on the right-hand side of the middle element since the array is sorted. So we now perform a binary search on the right half of the array. We start by finding the middle element in the array. When there are two items, the first item is the middle item. We once again check if target is now equal to the middle element. This time it actually is, and we return the index of 6, which is 3. I hope you've got a general idea of how binary search works. All you have to do is find the middle element, compare, and remove half of the array based on where the target element may lie. If the target is less than the middle element, you can get rid of the second half. If the target element is greater than the middle element, you can get rid of the first half. The middle element serves as a good comparison element to decide which way to narrow down. Alright, now that we have understood how binary search works, let's implement the code in the next video.
Okay, that is actually... Oh, okay, the binders, I think we kind of learned it before, but again, I don't widely remember it, I think, in the algorithm one. I don't know, let me check my notes. My notes, it's a bit messy, but... pointer short. Memory, pointer arithmetic. Recur, is it log of n? It's gonna be log of n, right? Because it keeps the input size half. Yeah, binary search is log of n. Oh, it's like the door from Professor Milan's. Yeah. Okay, I remember, but I don't. Should I try it with Yeah, let's give it a try. Let's just give it a try. Oops. Binary search.js. Okay, so let's see based on that pseudocode. Yeah, it's gonna be wrong. It's gonna be wrong, and it's not gonna be correct. But I don't mind. We can try it. Okay, so it's going to take similar. It's gonna take array. It's gonna take target. I'm just gonna do AR and T simplicity. So if r.length, all right, if r.length is equals to 0, is it? Or like if array.length is less than 1, I think. If the array is empty, right? Then -1. Sorry, I forgot basic. I was it's like that. Sorry. If array length, because array.length returns the number of the content of that array. So if it's empty, it's gonna return -1. So how do we find the middle element? Do we divide it? How to find? Do we divide it? Do we make it like case if it's odd number, then it's going to be if it's odd number, let's just say like this 5, it's gonna be 5 divided by 2, but then round it to the top. I don't know if I'm I have a tendency to overcomplicate what's supposed to be a simple algorithm. I don't know if this is like, that's just how I would approach it to find like the middle, because if it's like okay, the one that is difficult is actually if it's an even number. Which one is actually the middle? Okay. If target is okay, so How to find the middle element of the array? Is it just n divided by 2? Okay. So if it's sorry, let me think. Let me cook. Let's just say it has 4. So we're gonna choose the second one, right? So the first, second, and third, and fourth. So let's just say there's only until like -5, 2, 4, and 6. And the target is 6. Is okay, if it's divided by 2, 4 divided by 2 is n minus 1 because it's going to be the first index, right? If the middle is going to be like the left one. Okay, this is actually gonna complicate me and probably lead me to a wrong decision. I'm gonna just this solution.
In this video, let's take a look at the solution for binary search.
But at least from my side is that if it's a depending if it's like an odd n like the amount of number inside the array, if it's like an odd, that means it's good. We need to just divide it. Let's say we have like 5. 1, 2, 3, 4, 5. 5 divided by 2 is 2.5. 2.5, we can round it to 3. That means it's going to be the 0, 1, 2, and minus it by 1. So both still need to either divide it the n number of the n dot length divided by 2. Probably we rounded it. I think we can round it, right? We can like round it. There's like a round something function, and then always -1. Even for the even array is also minus by 1, because let's just say we have an array of 4. We divide it by 2 is equals 2, but since we chose the okay, I don't know. I'm gonna need to watch the video. I'm just overcomplicating myself. Sorry.
I'm here on Replit with an index.js file. Let's begin by defining the function signature. Function binary search, parentheses, and curly braces. The function will have 2 parameters.
Okay, that one is at least correct.
The sorted array we have to search, and target, which represents the element we have to find in the array. For example, calling the function with an array being a list of 5 numbers and target equal to 10, 6, and 20 should return 4, 3, and -1.
Okay, that's is this correct? Now this is correct. Oh, okay, wait. That's correct.
One respectively. Now, from our pseudocode in the previous video, we know that finding the middle element is key in searching for the element. And for that, we're going to make use of 2 pointers.
Okay, no, definitely wrong approach, yeah.
Will point at the leftmost and rightmost elements of the array. So let left index is equal to 0, since array index starts at 0.
Okay, so this is a completely better approach than my, okay?
-1.
I see, okay.
In our example, left index is equal to 0 and points at the first element, -5, and right index is equal to 4 and points at the last element, 10. The next set of operations we repeat as long as the array is not empty.
So it's gonna be a while loop.
While loop with a condition
okay.
that runs the loop as long as the left index is less than or equal to right index.
Okay, yeah, this is a way better implementation. I'm totally overcomplicating things.
Or equal to right index. Now in each iteration, we find the middle element. So let middle index is equal to left index plus right index divided by 2.
I see.
If we have the
Okay.
number of elements, middle index might be a decimal.
Okay. Yeah.
So
Yeah.
we
This
add
is my
math
concern.
floor to return the lower integer value.
Thank you. Okay. Yeah. It's method floor. Yeah.
In our example, this would be 0 plus 4 divided by 2, which is 2.
Okay.
0
Yeah. So
right is 4,
a part of
left
my
is 2.
approach,
Middle
only a
index
little
points
bit
at
of,
element
yeah.
4.
But yeah, the 2 pointers one, I
We
don't
now
know
check
that.
if target is equal to the middle element. If target equals array of middle index. If it is, we return middle index. In our case, 6 is not equal to 4, so we continue. And now comes the interesting bit.
You need to add
We now
the...
decide if we should pursue the left half of the array or the right half. If target
okay.
is less than the middle element, so array of middle index, we change right index to middle index minus 1.
I see. Okay.
Else, that is, if target is greater than the middle element, we change left index to middle index plus 1. In our case, the target element 6 is greater than the middle element 4. So we change the left pointer to point at middle index plus 1. So left now points at element 6 and right continues to point at element 10. The left index is 3 and right index remains 4. And remember, we do this because the array is already sorted. We know that 6 has to lie to the right of the middle element since 6 is greater than the middle element. At this point in time, since left is less than or equal to right, that is 3 less than or equal to 4, we repeat the while loop. We calculate the middle index again, which is left plus right divided by 2. So 3 plus 4 divided by 2. That is 3.5, but mat.floor will convert it to 3 and middle index is
Okay.
now 3.
Yeah. Okay.
We check if the element at the middle index is equal to the target element. 6 is indeed equal to 6, and we return 3
The
as
6.
the middle
Yeah.
index position.
Okay.
And that middle index is the position of the element in the array. Our code will return from binary search function. Of course, if the element is not present, eventually our while loop condition fails. In that scenario, we return minus 1.
This is actually a much simpler one. The one that I thought it's a bit too complicated, but yeah. Or like the opposite of what is it? So okay, we have flat left equals to 0, flat right equals to r dot length minus 1, while left is less than right, left middle index, left middle equals math dot floor, left plus right, if t is equals to r middle, return middle. Are you using Vim? Yeah, I'm using NeoVim, specifically Astro and Vim. Because I was looking for like something lightweight, right, at the time to like write code while streaming. And like I don't really want to configure the new Vim from scratch, so I just use Astro and Vim. And it looks pretty good. Although yeah, it just works, and like I don't really need to um configure anything on my side. You know, I don't really need to wrestle with the Lua config or anything. I just use whatever it is, and this just for practice as well. No AI, no autocomplete, no. Okay, there is LSP, but no like AI autocomplete or prediction. Just basic text editor that only uses like 80 megabytes of memory, and oh my god, it's so good. Plus, you know, practicing the Vimotion, although multi-line editing, I still very inexperienced, and a lot of like commands or like recording stuff I'm not very familiar, but like basic navigating stuff I'm pretty okay right now. I think I've been learning for I started learning new Vim was I think it was around May, June, something, April or May this year, and I've been trying. Like I can't live without Vimotion on like even VS Code or Cursor or something like that anymore. You know, I really need the uh, the Vimotion. Huh. I see. Okay, wait. I forgot to put filters. There we go. That's why it was looking weird. Okay, now there is some space. Okay.
Indicates the element is not found. This is
So we have a pointer. Can Python work? Yeah, definitely can. You just need to you need to like install like inside of like Astro and Vim or whatever config you use or whatever like LSP or any like template something. But you can find the Python LSP. You can find like some Python linter or formatter, things like that. And yeah, basically using the Astro and Vim, yeah, it has a very it's getting close to like IDE stuff, you know, with the extension and stuff. So this one, but I do have like my own Lua config in my GitHub, but it's kind of broken and I haven't had the time to fix it, or like I don't want to fix it because it's hard. Like I just use this. It's very, I mean, like I'm only using this for like testing anyways. Not testing, I mean like I'm only using this for when I stream anyways, or sometimes when I need to do a quick or see uh, files or edit a little bit of files very quick. Like I could just open nvim and then the file name and just open very quickly compared to like when opening VS Code or Cursor it took like a few seconds. But using this, it's super quick. There we go. Okay, so we have Lua, we have Biome, HTML, and Tailwind. Okay. Really? Okay. Let's do TypeScript. Let's install the TypeScript language server. And looks good. I think I already have Biome installed for the formatter and linter. But yeah, Python can totally works. I think there's a lot of YouTube tutorial or at least like some guide or someone's GitHub or like someone's new Vim config for like Python. I think yeah, it's totally doable. Cool. Okay, let's try to run it. So we can do Control-Shift-W. Okay, that is not what I want. That is a wrong command. To add a new tab, Control-Shift-T. Sorry. It's been a while, you know. Control-Shift-T. Okay, the search doesn't work, apparently. So we can do cd stop DSA study clear, and then ls we have node binary search, and it should work. Yes,
That's pretty much
lovely.
your binary search algorithm. Let's verify by running the code. Click on Run,
And it worked.
and we see the 3 values corresponding to each function call. Our code works as expected. What I would like you to do is take a pen and paper, trace the function execution for this array, and target is equal to 10. That will improve your understanding of the code we have written. Alright, next it's time to determine the big O of our binary search function.
It's log of n. It's log of n.
And determine the big O. Here is the cheat sheet, which can be used as a guide. Pause now, or let's estimate the big O together. Our function contains one while loop, but the detail is inside the while loop. In every iteration, we reduce the input size by half. So the time complexity of our function is O of log n and not O of n.
Because it decreases the input by half, right?
N here refers to the size of the array. The number of instruction executions increases as n grows, but not by the same amount. Time complexity is logarithmic and not linear. Alright, in the next video, let's take a look at the recursive solution to binary search.
Oh, okay. This one I need to clock in, you know. Recursive binary.
In the previous video, we had a look at the iteration.
Because that means we can, yeah. At first I was like, okay, if it's like something like this, like divine, we can use recursion, right? I think the professor even mentioned it in CS50, but
in this video, let's understand the recursive solution. To help you recollect, here is the problem statement from the previous video.
Given
a sorted array of n elements and a target element t, find the index of t in the array. Return -1 if the target element is not found. We've also had a look at a few examples in the previous video. If you have a sorted array with 5 numbers, -5, 2, 4, 6, and 10, and target element t is equal to 10, our solution should return 4 since 10 is at index 4. With the same array and t is equal to 6, our solution should return 3, and with the same array but t is equal to 20, the solution should return -1 as 20 is not present in the array. If you have understood the problem statement, please pause the video and try solve it. Remember, you have to make use of recursion. And when solving problems with recursion, 1. Figure out how to break down the problem into smaller versions of the same problem, and 2. Identify the base case to exit the infinite flow of code. Alright, let's now solve the problem together. Let me bring up the pseudocode we discussed in the previous video to help us with the recursive approach. Luckily for us, the first 2 points in the pseudocode address the base case for our recursion, and the last 2 points help break down the problem into smaller versions of the same problem. So if it
Okay, that doesn't work. Couldn't do that. Okay, can I do?
Either the array is empty, or if the middle element is the same as the target element, we exit from recursion. If target element is less than the middle element, we take only the left half of the array and perform the same binary search. If target is greater than middle element, we take only the right half of the array and perform the binary search. The pseudocode, as you can see, pretty much explains the recursive solution. Let's go back to Replit and implement it. Let's begin by defining the function signature. Function recursive binary search, parentheses, curly braces. The function will have two parameters. ARR, which represents the sorted array we have to search, and target, which represents the element we have to find in the array. For example, calling the function with array being a list of 5 numbers and target
I know there has like a faster way to do it, but it's fine.
equal to 10, 6, and 20.
So how do we do this?
4, 3, and -1 respectively.
Recursively, of course.
However, the function body is quite different, as we will rely on a helper function that will be called recursively.
Oh, okay.
So we are going to return a function called search, which will accept 4 parameters. The first 2 parameters remain the same, array and target. The third and fourth parameters, though, will be the left index and the right index. On the initial call, left index will be 0 as it points at the first element in the array. Right index will be array.length -1 as it points at the last index in the array. That is all there is to the recursive binary search function. Let's now define the search function.
What?
First, the function signature. Function search, parentheses, and curly braces. The parameters are going to be array, target, left index, and right index. Within the function body, let's add the base case first. We have 2 base cases in this scenario. First, if left index is greater than right index, we don't have any more elements in the array to work with, and hence return -1, indicating that the element was not found. Second, we calculate the middle index and check to see if the middle element is equal to the target element, and if so, return the index. This is no different from the previous video, so let me quickly go through the code. First, we find the middle index. Next, if target is equal to array of middle index,
It's gonna return the middle index.
If the element was not found at the middle index, we need to recursively search either the left half or the right half of the array. And here is how we do it. If the target element is less than the middle element, the target is less than array of middle index, it implies we have to search the left half of the array. So we call the same search function, passing in the same array, target, and left index. But this time, the right index will be middle index
-1. I see. Okay. Yeah.
Else, if target is greater than the middle element, we we need to search the right half of the array. So we call the same search function, again passing in array target, but this time left index will be middle index,
yeah.
And right index will remain the same. This represents the right half of the array. Make sure to return both the search calls.
This is way longer than the regular binary search. Okay, let's try to... We have array, we have target, we have left, and we have right. If left is greater than right, return -1. Let middle equals to math of flow. Left plus right divided by 2. If t equals to array middle, return middle. If this is splitting it, t, that's an r middle. So search rt left, and now it's the middle -1 because it's the left side. Else return search for rt middle +1 right. And this should work.
Let's verify by running the code. We see the 3 values.
Quite similar, but I kind of like this approach more. This is much simpler.
Our code works as expected. What I would like you to do is take a pen and paper, trace the function execution for this array, and target is equal to 10.
Okay, let's do that. Let's target it with our recursive binary, basically. So okay, let me try to run it first. Four, 3, 1. Okay, it's the same. So let's trace the binary one by one if it's looking for 10. So first, recursive binary. It's just gonna take the 2. It's taking search, taking array target 0 array dot length -1. So let's just say the array is again -5, 2, 4, 6, 10, and we're looking for the number 10. It's first going to put, it's gonna call the search, and then we have search. Inside search, if left index, if left is bigger than right, so we have array.length. Array.length is going to be 0, 1, 2, 3, 4, 5 -1. So this the right is going to be 4. So since left is 0 and right is 4, this doesn't work because left index isn't true. So it's gonna skip it. So it's not gonna return that. It's gonna get out of that block. And then we have a new variable called middle, which is basically the flow of the left plus right divided by 2. Since left is 0, and right is 4, but since it's an even number, we don't need to floor it. We don't need to like round it to the bottom. So it's gonna be middle, it's going to be 2, right? And then we're checking again if target is equals to array. And since middle is 2, so we're gonna put array of index 2, and in this case the index 2 is 4 and it's false. Since it is false, it's gonna get out of that if statement block at line 11 and 13. It's gonna go down, and if in this case return middle, if target is less than AR2 in this case, target is 10, which is false again. So it's going to the else case. So it's not that if false, It's gonna do another search with array, target, left, and then middle, but -1. But because it's not less than, it's actually going into the belows, the search below else, where it's the middle index. The middle index in this case is still 2, and the right index, oh, so middle plus 1, so this is going to be 3, and the right index is still 4. Because we don't do any switching. And now we go back into the search again at the top. And since the middle index plus 1 is now the left, middle index plus is 3, and right is 4, left index is smaller than the right index. Oh, sorry, no, it goes back to the top. Left index is 3. And is it higher than 4? No, it's not. It's gonna go into the middle index again. And now, since the left index is 3 and the right index is 4, they became 7. Divided by 2, floor down, it's gonna be 3. So middle is gonna be 3, the same as the left, basically. And now, target, since we're looking for 10, the target is 10, is it equals to the third? So 0, 1, 2, 3, it's 6, so it's wrong. So it's gonna go into the bottom again. And if target, in this case, is 10 less than the 6, it's wrong, and it's going to be going down here. Now it's going to do into the else, and right now the middle index is gonna be 4, right? And the right index is 4 again. And since, okay, to be honest, today, is it just gonna keep going down into like the last search? And the middle suddenly becomes 0, 1, 2, 3, 4. The middle becomes 4. And since if 4 is greater than 4 is incorrect, it's not gonna return that. So I think it's gonna go down until the middle index is 4 plus 1, so it's gonna be 5. And when the left index is already 5 and it's greater than the right index, it's just gonna return okay, I'm confused now, but it works. Okay, never mind. I'm just yapping.
That will improve your understanding of the code we have written and help you form a better mental model. recursive solution. Alright, next it's time to determine the big O of our recursive binary search function.
Would it still be the
Although
same?
we don't have any loops, we do have the same function, search, being called over and over again.
Is it still log open?
But the input size does reduce by half every time. So the time complexity of our recursive binary search solution is also logarithmic. Big O is equal to O of log n.
Cool.
With that, we have covered the main search
Nice.
algorithms, linear search and binary search. We have also had a look at the recursive solution to binary search.
Ooh, the sorting one. Okay, the sorting, the bubble sort is because you have like 2 for loops, right? That's gonna be
Please do consider subscribing to the
kind
channel.
of 2, blah, blah, blah. Okay, yeah, and it's just gonna keep swapping until like boop, 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 this is greater than, it swap, greater than, swap, and it's gonna loop again.
Search algorithms.
Yeah.
In this section, let's focus on the sorting algorithms. Sorting, as you might have guessed, is really important in web development and programming in general. You typically tend to sort by newest item first, or the item with the most number of upvotes. In this course, we will keep it simple and learn 4 different sorting algorithms to arrange elements of an array in a specific order. And yes, we will be working with numbers and sorting them in ascending order, since that is the simplest scenario for beginners like us. The 4 sorting algorithms we will learn about are bubble sort, insertion sort, quick sort, and finally merge sort. The approach remains the same as math and search algorithms. I'll start off by mentioning the problem statement. What is the ask from us? I will then request you to pause the video and try solve the problem.
Let's see if I still remember using the bubble sort. I don't think I
recommend you code along with me rather than just watching the video. Finally, we will determine the big O time complexity of our solution. Alright, let's get started with bubble sort in the next video. For our first sorting algorithm, let's take a look at bubble sort. For our specific scenario, here is the problem statement. Given an array of integers, sort the array. Sorting can either be ascending or descending. For example, if we have an array of 5 integers, -6, 20, 8, -2, and 4, passing the array into a bubble sort function should return the same array in ascending order. Before we start, I want to mention that bubble sort is a poor sorting algorithm in real world and is primarily used as a good introduction to sorting algorithms. That is intention in this series as well. You might never use this apart from interviews and as a stepping stone to other sorting algorithms. Having said that, please do make sure you understand how the algorithm works and not skip the video. This is also the video we would understand in a bit more detail compared to the next 3 algorithms. Alright, let's begin. Let's first understand the idea behind bubble sort. With bubble sort, you compare adjacent elements in the array and swap the position if they are not in the intended order. Repeat the instruction as you step through each element in the array. Once you step through the whole array with no swaps, the array is sorted. Confused? Well, let me help you.
Yeah, to be honest, I get how it works, but don't know how to implement them to code, to be honest.
-2 and 4. I have omitted the comma intentionally. Here is how bubble sort works. First, check if -6 and 20 are in order. They are, as -6 is...
Is it gonna be another 2? I forgot. 2 pointers again?
Check if 20 and 8 are in order. They are not. Swap 20 and 8. Next, check if 20 and -2 are in order. They are not. Swap 20 and -2. Check if 20 and 4 are in order. They are not. Swap 20 and 4. We have now reached the end of the array. At this point, we check if elements have been swapped. If they have, repeat the comparison from the first index. Start with -6 and 8. Are they in order? Yes. Check 8 and -2. Swap since 8 is greater than -2. Check 8 and 4. Swap since 8 is greater than 4. Check 8 and 20. They are in order, so you don't have to do anything. We have now reached the end of the array. Again, at this point, we check if elements have been swapped. If they have, repeat the comparison from the first index. So start with -6 and -2. They are already in order. Check -2 and 4. They are in order as well. 4 and 8, they are also in order. Finally, 8 and 20. They are in order once again. we have reached the end of the array. We again check if elements have been swapped. None of the elements have been swapped. Now if that is the case, the array is sorted. This is how bubble sort works. In each loop, the highest number is said to have bubbled to the top, hence the name bubble sort. 20 in first iteration, 8 in the second iteration, and so on. Alright, if you've understood the algorithm, now is the time to pause and try implement the solution. If you would like to solve together, let's do so in the next video.
No, I'm still not entirely sure, but let's see how it goes.
In this video, let's take a look at the solution for bubble sort. Back here in Replit, let's begin by defining the function signature. Function bubble sort, and this will have one parameter, arr, which represents the array to sort. For example, if we have an array of 5 numbers and we pass that array into the bubble sort function and then log that array to the console, we should see the elements sorted in ascending order. Now what do we know about bubble sort? We know that we start at the first element in the array and compare adjacent elements till we reach the last element. That sounds like a loop. Let's begin with that. For let I is equal to 0, I less than array.length minus 1, I plus plus, and curly braces. Within the loop body, we compare the element with the adjacent element and swap them if they're out of order. So if array of I is greater than array of I plus 1, swap them using a temporary variable. So let
Okay, yeah, oh yeah, I remember. The temporary variable, okay.
Is equal to array of I plus 1. Array of I plus 1 is equal to temp. These 3 lines swap 2 values and it's pretty helpful if you can remember it. One thing you might have noticed is we stopped at array.length minus 1 since we compare I with I plus 1. In our slide, you can see 4 is compared with 20 and that is effectively our last element. There is no need to compare 20 with an element outside the array. Alright, with this for loop, we are now making one pass of the elements in the array. Next, we implement the logic to check if we should repeat this loop. And what is the check? Well, if elements have been swapped, repeat the comparison. To keep track of that, let's create a variable.
Okay, yeah.
Now, we are going to wrap the for loop with a while loop. To be more precise, a do-while loop. To determine if an array is sorted or not, we have to go through the elements at least once. And that is a perfect use case for a do-while loop. So wrap with do and while. Now then, what is the condition to repeat this comparison? If the elements are swapped. So while swapped is true, keep running the for loop. But how are we changing this swapped value? Well, at the beginning of do while, set swapped is equal to false. And then within the for loop, if you are swapping the elements, set swapped is equal to true. And with that, we have implemented bubble sort. Let me summarize the code.
Okay, yeah, I get it, because it's so only, yeah, I get it. This is where it's good for doing do while, because it's gonna keep on looping until it's like true, and it's just gonna be false once this looping is okay. Yeah. Because we basically create a temporary variable to store the first number. Let's just say it's -6, and then we have this is if since -6 and -2 is already correct, it wouldn't, it's just gonna run through this. Oh no, so if array of 0, which is number 6, is greater than 8, which is false, so it's just gonna skip from this to just go back for the 4, and then it's gonna increment this, so it's going to be 1 right now. Di equals to 1, so since this is going to be the first, which is -2, and this is what's going to be -4. Oh wait, sorry. If it's 8 and 20. Since the 0th index item is 8, is not greater than 20, it's gonna go here, and it's gonna go to 1, which is 20, and then the I plus 2 is going to be -2, and since it's correct, it's gonna create a temporary variable to store the 20, and the 20 is now going, it's the array 1, it's going to be switch with the -2, and the I want, which is the second, the 0 one, the second index is gonna be the 20 value that is set up in the temp, and it's gonna make the swapped into true, because that did happen. So since swap is true, the if is done, it's gonna go here. And while swap is still true, it's gonna, okay, I don't, okay, okay. Why do we put the swap there? I see, okay, I kinda get it.
We begin by going through the array at least once. We check if any adjacent elements are out of order. If they're not, we exit the do while loop since the array is already sorted.
Yeah.
If we did swap elements, we go through the array again to make sure there is no more swapping required. If we encounter a swap, repeat the process. If we don't encounter a swap, the array has been sorted. I would recommend you trace this code with the slide we have here, and that will give you a much better understanding. All right, let's verify by running the code. We see the sorted array. Our code works as expected. What I would like you to do is take a pen and paper and trace a function for a different array. Perhaps once for a sorted array and once for a reverse sorted array where the elements are in descending order. That will really help you cement bubble sort algorithm in your mind. All right, next it's time to determine the big O of our bubble sort function.
This
pause for a minute and determine the big O.
Is n of 2, because it has
Here
like,
is the cheat sheet which can be used as a guide.
this loops, right?
Pause now, or let's estimate the big O together. Our function contains two loops. A for loop that is nested inside a do while loop. From our cheat sheet, it is pretty evident that the big O is quadratic time complexity. Big O is equal to O of n squared. As the number of elements in the array increases, the number of comparison increases by square of the number. Quadratic time complexity isn't great for sorting. But for now, I hope you were able to understand the bubble sort algorithm. Thank you for watching. Make sure to subscribe to the channel, and I'll see you in the next video.
Cool. Okay. So let's go to the next one. And I think I'm gonna, it's beautiful. So we're going to see what the solution I made in the last video. We got share person see I didn't have time to worry about news. This is using this. I forgot what. Yeah, but it's like it works as well. Destructuring operator. Yeah. This one. Yeah. I like it. I like this one. And using the double for, but he's using double for, no? Okay, cool. What else? I think I don't know. To be honest, I'm quite tired today, and probably I'm not gonna do that much because tomorrow is Monday anyway. I'll try to stream again tomorrow. Just keeping it short, keeping it consistent, and I guess thank you for watching. You know, I'm just gonna keeping it short tonight. Just a few sorting, a few DSA, and yeah, hopefully we can finish this and try again tomorrow. And yeah, at least I do a little bit of coding, a little bit of practice also. Most of it's just being confused, but it is what it is. I guess I'm just gonna keeping it short. Hopefully everyone have a great day, or great night, or evening, or afternoon, or wherever you are. Yeah, it's quite short today, only 1 hour, but trying to show up every single day, bit by bit. I'll see you guys again tomorrow or in 2 days or somewhere.